Okay, looks like the stream is a bit more stable this time. Okay, let's hope for the best. So I will be, well, trying to show you some features of p5.js, which is a JavaScript version of processing. And there's an editor at p5.js.org, which you can use to write code and execute it right in the browser. And we will use this framework to create a little vertically scrolling starship shooting game. So shoot 'em up vertically. Well, okay, let's have a look at the editor right there. I'm here at editor.p5js.org, as you see in the address bar right on top. And on the left side, we've got two JavaScript functions which are pre-configured. Sorry. One is called setup. This will be executed once and creates the actual, well, playing area. And then there will be, there's a function called draw. And this function is called repeatedly every time a frame is drawn. And the canvas itself is 400 times 400 pixel great, so I guess we won't have performance issues right there. Well, okay. Now, what does it do? If we're clicking on this gray button up here, which has the play symbol on it, this so-called sketch will be executed, first setting up an area of 400 times 400 pixels, and then the draw method will be executed, drawing a background with a brightness of 220, so this will be a grayscale. So right now this does almost nothing. There we go, just draws a gray square, and that's it, and nothing happens. What I want to happen is that there will be well, for once, that we get a really black space-like background, and that there are stars appearing, and these stars should scroll from the top to the bottom, so we get the impression that our spaceship, which will be appearing much later, is flying from the bottom up to the top. So, okay, now we need to, well, change the background. I'll stop the sketch from running. I'll enter 0 right there, and this should set the background color to just plain black. There it is. Okay. So that was easy. Now we need to draw, well, these stars, and the most primitive approach to that would be, well, painting just, or drawing just tiny white dots. Okay, how is this done in p5.js? Well, there is, if I remember correctly, a function called ellipse, and this function receives, I think, 4 parameters. Just have a test with this, and we start at 1010 and add a 5.5 right there, and I think it's this is the center point, and then we get 2 radius parameters, but we can also look that up instead of guessing. So let's have a look at p5.js ellipse. There it is. So drawing an oval, yeah, okay. And what is this? Yeah, x and y. Define the x coordinate of the center of the ellipse, the y coordinate of the center of the ellipse, and then we've got a width parameter and a height parameter. So let's go with that. see what happens, and we are drawing a tiny white dot up here. So the default color, or almost white color, the default color or the fill color, we might want to change that. So let's try something like that, call fill, which changes the color with which areas are filled in p5.js and in processing, of course. And let's go for a very drastic color. Just say for the first channel this would be red 255, which would be the maximum value, and let's give green and blue a 0, so we've got a very intense red. So there it is. All right, so now we know how to draw well, our stars and how to color them. Now, how do we actually get these stars to appear in crowds? And secondly, how to move them upwards? Well, we can go for the frames counter, and if I can remember rightly, p5.js has a property called frame count. Frame count, there it is. Let's have a look at it. There it is. Okay. It's just a number we can refer to with the name frame count, and well, it just counts the rendered frames, so we can use that to move our stars once we define how to draw them. In a very primitive approach, this would just influence the y value of our ellipse right there. So we could go there and say, just take the frame count, and each time the frame is rendered, remember, draw is called every time the frame is rendered, the y value would be different because the frame count changes. So let's have a look. Yeah, so we see a very steady falling red dot. It's already the right direction, so this is not so bad. And when we are making our stars dependent upon the frame count, this should somehow influence the y value. So this is one idea we can keep. Now we need not only to draw one star, but several, and so we would need some kind of, well, data structure, some kind of array to keep track of them. And so I'd go here and say, let's define a little array. And in JavaScript we've got let and const, and let defines variables that are about to change during the execution of the program. And since our array might contain a variable amount of stars, it should be declared with let, and we just give him a name, calling it stars. So like that, not star, but stars. And then I will assign an empty array to this variable, and we can start adding stars to this array in the draw method because it's called repeatedly. So okay, let's start with one star per row of pixels. And well, how to get there? Well, we need some kind of random x value, I guess. How to create this? Well, let's call this randx, and JavaScript has a random function. Let's look that up. Math random JavaScript. Okay, there we are. And it returns a point number between 0 and 1. And 1 is not included, but 0 will be. So once we are using this, we'll generate a number, math random, between 0 and 1. And if we multiply this with another parameter, we will set with another variable we'll set called width, this one, which refers to the width of the drawing board, of the canvas. We will have a number between 0 and the width of the whole drawing board, of the whole canvas. So now this will be an usable x value. Let's take this and call it star x. Good. Now, okay, now we've got an x value for our star. And what about the y value? Well, the y value should change, and maybe it should be stored also in the stars array. Okay, let's just say we've got a star y right there, and for the time being, let's memorize the current frame count there. So we'll start at 0 and then start from there. Okay, now we've got an x coordinate and a y for our little star. Now, how to put that or get that into our stars array? Well, let's put it together and have a little JSON object. JSON is structured as a data structure called an abbreviation for JavaScript object notation. So, okay, let's get this going. Our star is now star chords, and we're opening curly brackets. So there's an x, which will be this randomly generated x coordinate, and y, which will be the frame count, the current frame count right here. Now let's take this and, well, draw a star right there, just to test it out if we can get this working. So this would be star chords y, and this would be star chords x. So, all right. Now this won't be much of a this is not much of a progress. We just and we also haven't used the stars array right now, but well, still this changed quite a lot. So now the frame count increases, and sometimes, well, after the first 400 frames are done, we no longer see any action here. So obviously there's something going on. We got to change this. We got to somehow use the frame count to maybe change the behavior of the stars, and perhaps we shouldn't use it at all, or just we could introduce another variable right there to just push our stars further down. So maybe yeah, let's do it that way. Just forget the frame count. It's still interesting thought, but maybe it doesn't serve our purpose too well. So let's put the star coordinates here and have the y set to 0, or let's say, okay, this one, and now it won't move at all. So after a while we just have a red line right there, I thought. Or let's do it this way. Yeah, all right. Doing something. And of course, when we are removing the background from the drawing, then it will draw and accumulate red color right there on the top of the drawing area. We're seeing there are several dots drawn. Now let's get this back into the draw function right there. So we're here. Okay, let's get this going. Keep it this way and store it in the stars array. Stars push star chords. Good. Now we've got one star in the first iteration, or in the first first calling draw, and for every frame there's another star added right there. So once the second call to the draw function appears, we could say, okay, let's see which stars are already present in the stars array, and we could move them further down. So how do we do that? Well, we could loop through the array right before we create the new star, and this is done in JavaScript with a for loop. For example, since ES6, I think it was, there is a possibility to use for off. So let s for little star of stars, and now we're just increasing the y value of this star by 1 using this operator. We could also use the double plus, so the y value would be incremented by 1. Good. After that, we can create another star. This will be placed also in the array, and then the stars that have been created earlier would be deeper, so we get no longer this. There wouldn't be the red line up there, but the stars start falling, or rather floating, or so we get the background for our little shooter game. Okay, now let's okay, we pushed the star right there, we set the fill color, which should maybe not be that red. Maybe we can just go with white or with the default color. And let's reduce the circumference of, or the radius of our little star by, well, I think 1 should be enough. Stop the sketch, restart the sketch. Is anything happening? No. Why not? Well, maybe this was not enough. At least 1 should be drawn. Still can't see it. Strange. New stars there. We added the stars. We have pushed the stars down. Well, we could, for example, draw another star. Let s of stars, and let's have them be drawn right there. So S and S, that's not looking too good, so this one, stop, go. Yeah, and now it's looks a bit more like rain, and funny, kind of an optical illusion. It almost looks like they're moving at different speeds, but different speed. But this is not the case. All right. So there's our little star field. Now let's have a look at the code. It's starting to become messy. That's not so beautiful. Now maybe let's organize the code in, for example, a class. We could create a class star field, and this class should keep track of our stars and maybe clean up the stars once they reached a Y value which is so large it no longer is displayed. So then the star should be removed. So a little cleanup step wouldn't be bad. Maybe we could integrate it right there. Okay, but first let's create a class for these stars. Okay, class, let's call it star field. Now there it is. And well, in the constructor of this class, we will define, well, the number of stars per row. So this number of stars per row, and we'll start with just 1. And we would also need to remember the size of the stars in the star field, maybe a range later, something like that. And the star itself would have to remember how big it is. Well, let's just keep it simple. So let's say this star size is, what did we do? 2, right there, 2, which would go into the width and height of the call to ellipse. So now we get a star field right there, and the star field needs a draw function, and this function will be called from within the main draw function on our star field instance, which is not yet existent. So now we've got the class, we've got 2 fields within the class, and there's a third field we really need, and this will be called stars, and you guessed it, yes, this will contain our stars. So we will get rid of the already existing stars variable, this one right there, and yeah, this looks like it could just take care of the code we already produced. Right there it is. Okay, so now we've got our draw method right there. So now what's he doing? Okay, for let s of stars. This is no longer existent. Instead we've got the array, so that would be this one. We are increasing every star we get, and we're increasing its y value. Then we are creating a new entry for the stars right there. Okay, math random, and y this. Width is globally available, so this should still work. And this, of course, has to be qualified with this stars, since we are referring to the field within the class. And then in the next loop, we also have to make this dependent upon the class or the instance. And ellipse is a globally available function again. So that should do the trick for the first part, and we can already get rid of these magic numbers right here. So this star size should do it. So, okay. Number of stars per row. This refers to the part where we are creating new stars. And of course, well, we could also put that in a for loop. For lack of creativity, let's do this. Okay, let I 0, I smaller than this num of stars per row, and finally I plus plus. So we are looping through the commands I'm just about to put into this loop right there, and we're calling it for the number of times this variable holds. And well, this should produce something like the effect we're already seeing here, which is of course a bit difficult to see in the stream, so maybe I should increase the star size right there. Okay. Now, I haven't been starting the sketch again. Let's create another variable called star fields. Maybe we'll have another one, so we could keep track of them in an array. Oh well, let's start with one. Just have a star field variable, star field, and we will populate this in the setup and say, okay, new star field. Oh, did I camel case the field? Yeah, I did. Okay, so this should be okay. And then we're going into the draw method and calling the draw method on the star field. So just passing on the call to the method. There we are. Well, now well, let's see if I created some errors there. Yeah, oh, that is interesting. Now, okay, stars are of course a bit bitter, but I would have expected to make some typos somewhere, but obviously it works. Fascinating. All right, now we've got the first star field, which is nice, but well, we could improve upon that, I guess. Let's see, how could we clean up the code a bit? These 3 loops are, I think, ugly. How do we do this? So we could, of course, put the incrementation of the y property on our little JSON stars in the drawing step right there. After all, why not? So let's move this line after the drawing right there. So every star's y value will be incremented after it is drawn, which essentially does the same like our code from before, but with much less lines of code. And now we're doing is what we're now doing is we are creating stars right here, and we're drawing stars right here. So maybe we could break this down in two different methods on this class, and I think this would improve our code. So let's have another method called create stars right there. So, and we will move our for loop that creates new stars right into this method, and then we are calling this method from the draw method on our class. So let's say create stars right there. It is. Okay, so this should do the same thing as we did before, and the drawing of the stars is still within the draw method. Okay, I think I can live with that. It's still not a beauty, but well, okay, let's keep it. Let's leave it like that for the time being. Okay, now we've got one star field, and well, this is already nice. Imagine if there's some starship floating along right here, you'll already get the impression that you're traveling upward, which is nice, but I think some parallax-like effect would be nice. So another star field, either on the front or in the back of our already existing star field would be nice. So how do we do that? Since I don't want to use 3D rendering right there, which would be a vast drain of resources, we will just recreate another star field with other parameters in terms of star size and brightness. So we didn't use the brightness or color yet. This will be one step. And we also didn't parameterize any of the fields we are initializing in the constructor of the star field. So this would be our first step. We are using constructor parameters as, for example, num of stars per row and the star size, and both of them we'll be storing both of them in the fields with the same names. This is just right, so that should be okay. Now we need to set these once we instantiate the star field, which is right here. And well, let's give it, well, the first one is num of stars per row. There we'll take 1, and then star size, which was 3 for this one. And then the overall appearance should look like the star field we are already seeing. Well, let's see if I made some typo, some mistake there. Have a look. Just try this out. Looks like I messed something up. Star size, okay. Create stars. Didn't change much. Star field, is there. Star field draw. Oh, why doesn't this? Strange. So stars per row. A bit baffled. How come this doesn't do as we expected? Now let's see what we can do. Stars per row, star size. Strange. Let's undo my changes right there. And oh, it still doesn't do anything. Strange. What did I change? Okay, let's return this to the former state. And now it works. So it's something to do with our refactoring there. Okay. Control-Shift-Z. So why is this causing... of course. Now this is a common mistake, and I really hate JavaScript for that. You have to qualify everything you need to call on the current class with this. So JavaScript tried to call create stars function somewhere in the global space, but didn't find it, and I have to write this dot in front of it to say, okay, use your own method. This is one thing which is really much more beautiful in Java, though Java itself isn't that much of a beauty. Okay, so let's stop that and start again. Yeah, looks good. So I can redo the parameter approach up here. Number of stars, this was fine in the first place. And star size. So let's take this one, put this down right there. Star size also right here. And we are passing the parameters, or we are putting the actual dimensions into these parameters when we instantiate the star fields. So let's go. There, it's still working and it still looks like we are used to. Now let's have a second star field. Let's star field 2. So where are we? There are we. Okay, star field 2, same idea. Let's go there. We could just copy this line and change the names. Star field 2. And this star field gets, well, smaller stars. And this should be enough to have a slightly 3D-ish impression. Star field 2, draw, stop, go. Yeah, and now we see all the stars moving at the same speed, and some of them are brighter, some of them are not so bright or bigger, and some of them are not so big. Looks a bit nicer, but still not what we really wanted. What we wanted was a parallax effect, so we somehow need to change the speed with which the stars, which seem to be farther away, move. So how do we do that? Well, right now the movement, quote unquote, is this. This is our movement right now. And since the smallest unit we can use is a single pixel, we might have to change the speed right there. So we need another parameter, another constructor parameter. And let's say, okay, let's have speed right there. We'll add this field to our class, add speed. So there we are. And now we need to change the way with which the y parameter is increased. Say, okay, this plus equals speed, which has the same effect if speed equals 1, but it has the double effect if speed is, for example, 2. Now let's pass the parameter right there. For the bigger ones, speed should be 2, and for the smaller or for more distant stars, speed should be 1. Then they should, I expect this, to move with different speed on the canvas. Well, let's see if I'm totally mistaken or if this actually works. Well, actually no, something is missing, and I made for their speed is not defined. Sketch line 23. Yeah, and once again, this is so annoying in JavaScript. This is just, I can't tell you how annoying this is. Yeah, right. So, and there we go. So, it looks a bit like snow or rain in the first few frames, but once we reach the bottom, there we got 2 layers of moving stars. Maybe a bit too fast in the front. I wonder what happens if we are using fraction, if you're using floating point numbers there. Would that be possible? Is this creating usable results if you're not using 2 right there as a factor, or but 1.5? Well, let's see. Well, it doesn't. I thought it would look worse. Okay. Okay, let's go down to 1.3. And yes, this is much more closely resembling what I had in mind. And now we are having a little parallax effect. Now the problem we created is that in each of these classes, or each of these instances of the class, the number of stars right now increases indefinitely. And that's not very good because, well, reality usually has limits. And, well, let's go and clean it up. We should check for the stars if they are out of range and wouldn't be drawn anyway, that they should be removed from our class, from our array, so they don't eat up our resources of the computer. So we just call another method. We just invent this right now. Clean up stars. Right there. Put it here. Clean up stars. And now we will be looking through the stars. We'll create a new array of stars. As first, this will be a local variable within this method of the star field object, and we'll call this new star set. Oh, no, let's go with this. It's okay. Come on. Good. Now let's see how we can do this. One approach would be to just loop through the existing stars, as of these stars, and just check if a star has a y value bigger than 400. This would mean he's out of range. It's no longer drawn, so we don't need it anymore. And any other star is allowed to stay within the class or the instance of the star field. So let's have a look. How do we do this? We check the value of the star, see if s.y is greater or maybe even equal. Well, let's stay with greater. That's all right for the first time. And maybe not work with 400, but with height. So we don't have to rewrite this when we change the frame, the canvas. And if this is the case, then, well, the star should be removed. Yeah, this would be a bit tricky. Well, it's possible to remove this from the existing stars array, but we are already iterating over this array, so this it doesn't feel too good. So let's go in the different direction and say, okay, as long as you are smaller or equal to 400, you can stay, and then you are part of the new star set. So new star sets, push s dot so we just add this star, which is already in the green, to our new star set, and once all stars have been checked, all the stars that are still alright to be drawn and alright to be kept are within our new star set, and then we're just replacing the old star set with the new star set. There it is. So that's the idea. Let's see if I messed it up or not. And there we are. It still works, and now there we go. Seems to work. Let's log a bit of data to see if it's still, is actually removing stars right there. And let's write something in the draw method right there. Come on, let's do it. Console log. This refers to the browser console, which can be opened in Chrome with Command Option and I if you're using a decent computer, and with some other key combination if you're not using a decent operating system. So let's go there and have a look at the, is it length or size? This stars, I think it's length in JavaScript, isn't it? The number of elements within the array. Well, let's see if this is causing a problem. Ah yeah, alright there. So it counts up and up and up and up and up. Our array of stars gets populated, and then for no other reason than our new behavior just implemented with the cleanup method, it stays at 399 or respectively 306 for the bigger ones. And so yes, we did this, and it actually does what we intended it to do. It keeps the stars in line or in range or within boundaries, so we won't see infinite growth in a finite world. Okay, yeah, looks a bit like snowfall. Good. Now, could we improve on that? Yes, of course, we could improve on that. For example, we could have the stars modulate in brightness within each star field. We could have a modulation of size of the stars in each star field. Maybe the density of stars is a bit too high. I would like to reduce it in the for the bigger stars. Maybe we could have some nebula in the background, in the far background, which doesn't move at all. We could take some pictures from NASA right there, or from the European Space Agency, and put it in the background. Well, let's see if we can do something like that, but I think this will be a task for another session. So for today, I already think I annoyed you enough. So let's call this a day, and well, bye. Until next time, yours, Ingmar.